Okay, this section is starting the section 3.4 in the triangles unit in Math A30, and it's the ambiguous case. And basically, what the ambiguous case is when you get side, 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 angle, or a hypotenuse and leg, or two angles and a side, you are able to only draw one type of triangle. But if you get an angle with two sides, a certain type of case that you don't want to get, because when you get that case, you could get one triangle, two triangles, or no triangles, depending on what's going on. So it's ambiguous, we're not sure. So there's a test that you do to find out how many triangles you have. And what I'm going to do, first of all, is I'm just going to draw out an example of what we're talking about in terms of the type of triangles that you can find. So let's say we had a given side. Let's say, let's start with an angle that's small. So let's say we have this triangle here, and the angle is less than 90, let's say an acute angle. Like something like that. Now, it would help to have a compass, but I broke my compass earlier, so I'm going to have to use something else. But what we'll see is, let's say that this is angle B. And let's say that it's like 40 degrees or something. Okay? And let's say that this side here is just 20. Okay? Now, what you'll find out is that if you have a side here, we don't know what this side is, but if you have, we have this side given, right? This side, this angle given, and some side given here. If this side here given to us is that other side, if it's small, like if it's just 1, it'll never ever touch this here line. So if we had a real small side, say for example, like this is 4 or something, then you can see that no triangle in this case occurs because it's too small. Okay. Small, it's like small, and it can't even touch that particularly end of the corner. But if you got one that was perfect length, if side B was just perfectly long enough that it would touch here only, make a right triangle like this. If side B, in this case, you have one triangle, because side B is a perfect length. If you go just over here, you won't get anything. If you go just over here, when side B becomes perpendicular to the bottom side. Okay, so you can have another case where you have 1 there. Then you can have a case where side B, and I'm going to draw it here again. These are all, we're dealing with only acute angles, because there's another couple cases where we have, so we have this. And let's say side B is given such that it's long, and you can get it to come over here. So let's say we had, let's say that I'll use my ruler here and say I had it at exactly 4.5 centimeters, let's say. And it touched the line there. So we can have it, side B can work here. And let's say if I swing it around here, and it it eventually comes right here as well. There's two possible triangles with the same side length. You can have a triangle here and a triangle here when B has the perfect length to touch the bottom side twice. So you have this triangle here and this whole big triangle. So sometimes there's two possible triangles. B contacts the bottom side twice. Okay, and then there's one more case where you can get one triangle. If B was a really long side, okay, and maybe I'll draw a third one here just so I can't show you. Okay, got enough time, yep. If B was really long, we'd have just one triangle here. So if I had this same type of triangle here, and B was really, really long, let's say 7 centimeters, just on this little diagram that I've got, or something like that. Okay, so there we have, so if this was, and we wanted to find side B, and it was B was long, if we took this same side and went over here, it would be way, way, way over here. It wouldn't even touch this side. It would go past this point. So there's only one. When B is really large, but smaller than, or larger than this one and larger than this one, so that it comes out here. Okay, large here, but larger than this here side, so that it comes way out here. You get one triangle. So there is a check that they give you, and I'm not going to derive it here, in your book, to finding out which of the, for an acute angle, which of the 4 cases you deal with. So if you look on page 122, they summarize that there's no triangle if you take the adjacent side and the sine of this angle and multiply them together, and that is less than, or greater than, pardon me, if that is greater than the opposite side, you have no triangle. If it's exactly equal, if they're exactly equal, if the sine of this angle and the adjacent side is equal to the opposite side, you have the right triangle situation, or one triangle. If the two triangles, if there's two triangles, you'll have a case where the sine of the adjacent side here and the angle, the sine of this angle and multiplied by this adjacent side is going to be less than the opposite side. Okay, the two triangles. Or sorry. Yeah, and then also that's going to be less than this last side here. Or this side will be the longest side, pardon me, not this side being less. This side will be the longest side here between the sine of it and itself. So the sine of this one times this one will be longer than the original side, plus it'll also be longer than this side. Okay? And also they say that if side B is larger than the sine of this times this angle times this, then you have the one triangle because it goes past and makes this triangle. Okay, so we're going to look at that in our next tutorial, work with problems with those cases.